Cover the system. Hello, good evening, all of you.
Good evening, sir.
జాగ్రత్త. అవుతుందా? ఛార్జింగ్ అవుతుంది. వెళ్తావా? సరే వెళ్ళు. పెన్లు ఆడలేదు. Video and audio both are okay.
Yes, sir.
Somebody respond, please.
Yes, sir.
Right. Good. So in the last class we have discussed about the discrete and continuous random variate, and we did the problems given in the previous examinations. So now today we discuss about the binomial distribution. Please note down binomial distribution. Binomial distribution. If a random variate capital X, if a random variate capital X take finite number of 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 if it takes finite number of values, what we can say? It is a discrete random variate. Finite number of values. That is in a distribution, if the number of trials small n are finite, if the number of trials small n are finite, small n is finite, and the probability of happening event X is small p, probability of happening event small p is probability of event small x is given capital X is small p, and the probability of not happening capital X is probability of not happening capital X is probability of not happening capital X is small q. Small q small q. If such an event is occurred finite number of times. Finite number of times. Finite number of times. Then the probability of happening then the probability of happening then the probability of happening probability of then the probability of happening probability of happening such an event n number of times r number of times r number of times out of n trials out of n trials. I'm saying x is discrete. That means it is going to happen finite number of times. Okay. The probability of happening that x random variant is small p, and the probability of not happening that random variant x is small q. And out of n times, the probability of happening x in r times. Out of n times, the probability of happening that event x r times. The probability of happening such an event x r times small r times out of n times is. So I am choosing only happening r chosen out of n. It is going to occur r number of times out of n times. So r times you are getting that event. So that is p. P is probability of happening. It is happened r number of times. And so r number of times means p into p into p into so on p r times. And it is not happening 2 times with probability q. It is not happening with probability q. If r times it happens, how many times it doesn't happen? Somebody please write. If r times it happens, how many times it doesn't happen? N minus r times. N minus r times. If r times it happens, n minus r times, it doesn't happen. N minus r times, it doesn't happen. Say yes or no? Yes or no? I repeat this. Binomial distribution. Binomial distribution means in this only 2 possibilities are going to happen. That is, one is occurring of that event or not occurring that event. Only 2 possibilities. Okay, if you toss a coin, you may get head, not getting head. If you throw a cubical fate dice, you may get face 1 or not getting face 1. if you are writing an examination, you may get passed or not passed. Only two possibilities. When a person is considered, he may be aligned or not aligned. Only two things. Only two things. Write down. So P of x equals to R is equal to probability of happening such a discrete event, discrete random variable. Discrete means it is going to happen finite number of times. So if it is happening n number of times out of n, the probability of getting such event x r number of times is given as P of x equals to R equals to NCR. R chosen out of n. NCR. R chosen out of n. And it is happened with the P probability. So it is happened R times. P into P into. How many times it happens? R times. P into P into P into so on. P power R. And means multiplication. If R times it happens, n minus R times it doesn't happen. N minus R times it doesn't happen. So it doesn't happen with the Q probability. And we need only two things, happening or not happening. Okay. The probability of getting R successes out of n times is P of x equals to R equals to NCR P power R Q power n minus R. This happening may be considered as success. Not happening may be considered as not success. Not success. Have you written? Have you written or not? Somebody please write. Send the message, yes or no. Now here, sum of all the probabilities. Summation R equal to 0 to n. 0 means never happens. Up to n may happen up to n. Totally all the times it is getting success. Probability of getting R successes of x equals to R equals to summation R equal to 0 to n NCR P power R Q power n minus 1 is equal to how much? 1 is equal to 1. Sum of all probabilities is always equals to 1. Next, in binomial distribution, mean equals to mean of success is equal to n into p. N for total number of points, p for success probability. This is denoted by mu. Next, variance. Variance equals to denoted by sigma square equal to NPQ. So out of n primes, out of n primes, the variation between success and failure, P is for the success probability, Q is for the failure probability. The variation between success and failure, nothing but variance, denoted by sigma square equals to MPQ. And the standard deviation is nothing but sigma equals to positive square root of NPQ. Positive square root of NPQ. Okay, these are the things that we need to know based on the binomial distribution. So binomial distribution means if a distribution includes only two possibilities, one is happening of an event or not happening of an event. Happening probability is P, not happening probability is Q. So in this case, it is very clear. P plus Q equal to 1. Success plus failure probability summation always equals to 1. Okay. Binomial distribution means it takes only finite number of trials and it is purely discrete, not continuous. In any distribution, if we have only two possibilities, success or failure, such an event is known or such distribution is known as binomial. Only two, binomial. Because this probability of getting all successes out of n trials is nothing but general term in the binomial expansion. Binomial expansion of P plus Q whole power n. You please write a note. In binomial distribution, the number of trials are finite. Number of trials are finite. And there will be only two possibilities, success comma failure. Success comma failure. And success probability plus failure probability equals to 1. Success probability plus failure probability is equal to 1. And the difference between success and failure probability, the difference between success and failure probability is not so large. Is not so large. Is not so large. Okay. So in these three cases, when these cases arise, we use the binomial distribution to get the probability. Everybody got it? Please say yes or no. Yes or no? Please write the message. Please write the message, yes or no. Are you getting my voice? Hello? Anybody are there? Please send the message.
Sir, actually, chat option disabled, sir. Just now I enabled. Students, we can respond now.
Yes, yes. Okay. Right. Let us do some problems now, quickly. It takes only 1 minute. So my sincere request is you have to finish it in 1 or 2 minutes only. So not more than that. If you thorough about the concept, then it requires only 1 or 2 minutes. That's enough. Okay, right. A fair coin is tossed 5 times. A fair coin is tossed 5 times. 5 times. 5 times. What is the probability? What is the probability that at least one head turns up? That at least one head turns up. That at least one head turns up. At least one head turns up. Fair coin means you know better about the fair coin. You are going to have only 2 entities, head, comma, tail. No doubt. Fair coin means we'll get only 2 entities, head, comma, tail. Here we are discussing about head. So consider happening of head as success. Quick. Consider happening of head as success. Success. So small p equal to success probability, nothing but probability of getting head. Probability of getting head. That equals to 1/2. And the probability of not getting head is failure. Not getting head means tail. That is also 1/2. That is also 1/2. Here the number of trials are 5. As the number of trials are only 5, finite. So we have to use binomial distribution. In the problem, they won't give you that it is binomial or Poisson or normal. Sometimes if it may be given, if it is given, you can utilize it. If it is not given, then you have to say, or you have to utilize the binomial distribution when the number of trials are finite and when there are only 2 possibilities, success and failure, and the difference between success and failure probability is very small. Success probability is half, failure probability is half. Difference between them is 0. So you can use now. You can use binomial distribution. Write down, since the number of trials are finite, the difference between success and failure probability is small. The difference between success and failure probability is small. We can use binomial distribution. So probability of getting at least one head. At least one head means P of H greater than or equal to 1. Minimum 1 out of 5, minimum 1 head. Minimum 1 head means it may be 1 head, 2 heads, 3 heads, 4 heads, 5 heads. So minimum 1 head is required. That I am writing P of H greater than or equal to 1. So this you can write it as total sum of probability is 1 minus probability of not getting any head, 0 heads. 1 minus probability of getting 0 heads. So this is equal to 1 minus probability of getting 0 heads means total trials are 5, C0. Okay. small p power 0, 0 heads. We are discussing 0 heads into q power 5 minus 0. So tell me the answer. 1 minus 5c0 is 1, p power 0 is 1, q power 5 is 1 by 2 whole power 5. Can somebody say the value in terms of fractions? Quick. Somebody say the value in terms of fractions. Quick. Few people are taking much time, then it is not excusable. I have written everything. 1 minus 1 by 32. What is the value? (31 by 32). It was given in the gate for 2 marks. The answer is 31 by 32. Somebody please write the answer. Somebody please write the answer. Send the message. Yes, 31 by 32. Got it or not? Got it or not? Next question. Next question. Again, a similar one was given. In an experiment, there are 2 events, positive and negative. Positive and negative. Having equal chances of occurrence. Having equal chances of occurrence. If such an experiment is conducted for 5 times, if such an experiment is conducted for 5 times, such an experiment is conducted for 5 times, what is the probability that the negative event occurs at most 1 time, at most, ATMOST, at most 1 time. Negative event occurs at most 1 time. Write the options. 1 by 32, second option. 3 by 32, third option. 5 by 32, fourth option. 6 by 32. 6 by 32. Tell me the answer quick. That was also given in the gate. That was also given in the gate. Okay. less than a minute, we have negative. We are discussing about negatives, and negative is success. It is going to happen equally with positive. That is, probability of getting negative equals to probability of success equals to 1 by 2. Probability of getting positive equals to probability of getting failure also equals to 1 by 2. Here we are considering negative as, here we are considering negative as, negative as, negative as. We are considering negative as success. And that experiment was occurred for 5 times only. 5 times only. So here number of times are finite. Probability of success and probability of failure difference is small. It is almost 0. In such case, we can use binomial distribution. Note it. Number of trials are finite and probability of success, probability of failure have small difference. That means almost equal to 0. Now we can use binomial distribution. Binomial distribution. So the probability of getting probability of getting at most 1 negative event in that experiment, at most 1 negative. Probability of getting at most 1 negative. So P of negative at most means maximum. Maximum 1 time you need to get the negative. That means probability of getting negative less than or equal to 1. Less than or equal to 1. That means you may get negative for 0 time or 1 time. So probability of getting negative 0 time or whenever R sounds plus. Probability of getting negative 1 time. 0 time or 1 time. So this is equal. 0 time means out of 5 times, 0 time getting negative. Negative is success. P power 0. And not getting negative means Q power 5 minus 0 plus. At most 1 time means you may get 0 negative or 1 negative. So probability of getting negative 1 time means out of 5 tries, choose 1, P power 1, and means multiplication. Q power 5 minus 1. Q power 5 minus 1. This is equals 5 6 0 is 1. P power 0 is 1. Q is 1 by 2. 1 by 2 power 5. R means plus. 5 C1 is 5. P power 1 is 1 by 2. Q power 4. 1 by 2 whole power 4. Tell me the answer quick. 1 by 2 power 5 plus 5 by 2 power 5. The answer is 6 by 32. That was given among the options. Say yes or no. 6 by 32. Good. Is it clear? Is it clear or not? Yes. Right, next, another question. Right, next, another question. Another question. In a company, the probability that a defective pen, TN pen, manufactured is 0.1. Defective pen manufactured is 0.1. 0.1. 0.1. On a certain day, if 12 pens were manufactured, if 12 pens were manufactured, what is the probability that none will be defective? None, N-O-N-E, none will be defective. Second question. What is the probability that in the previous two questions we have discussed utmost, and in the previous one at least? Okay, at least means minimum that, utmost means maximum that, maximum up to that only it is allowed. What is the probability that more than 2 pens were defective? What is the probability that more than 2 pens were defective? I had given you two questions. So let me explain now clearly. So we have 12 pens manufactured on a certain day. Number of times finite. We are discussing about defective. So defective is considered as success. So success probability is 0.1. For binomial distribution, it is not required to give the failure. If the success is given, you may write the failure. If failure is given, you may write the success. The probability of getting success probability is 0.1. And the probability of getting failure probability is 0.9. Only success is given. So you may write this one also. This one also. Sum of these two definitely must be equal to 1. So number of times finite. Difference between success and failure probability is small. Difference between 0.1, 0.9 is not so much large. Right on. Here, difference between success and failure probability is small. So we can use binomial distribution. We can use binomial distribution. Binomial distribution. Right. So first question asked is none will be defective. None will be defective means probability of getting defective 0. That equals to 12 are given, 12 is 0. Success means getting defective and failure is Q, power and 0. So 12 is 0 is 1, P 0 is 1, and Q power 12, 0.9 whole power 12. Somebody say the value, you may use calculator now, but in the examination, you will be given. But in the examination, you will be given the calculator in the screen or in the computer. So you have to use that digital calculator. Use it and then tell me the value. 0.9 whole power 12. None will be defective will be 0.9 whole power 12. You can say the value of it by using the calculator. Second is more than 2. More than 2 means probability of getting defective greater than 2. Getting defective greater than 2. It is very simple. Greater than 2 means we have totally 12 pens manufactured. Maybe 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Writing all those is waste of time. Don't write like that. So if it is greater than 2 means you can write 1 minus probability of getting defective less than or equal to 2. Defective less than or equal to 2. From 1, you subtract probability of getting less than or equal to 2, you will get the value. So this is equals to 1 minus the probability of getting defective 0 times plus probability of getting defective 1 time plus probability of getting defective 2 times. This is the thing. Okay. 1 minus this. So you can write the value of it. You can write the value of it by using the calculator. 1 minus 12 0, 0.1 power 0, 0.9 power 12 plus 12 C1, 0.1 power 1 into 0.9 power 9 plus 12 C2, 0.1 power 2 into 0.9 power 10. 0.9 power 10. Please do it using the calculator or digital calculator. I'm not going to do the calculation, that is your choice. So here my ambition is, you may not be given exactly 2. Exactly 2 means directly you can write 12 C2, that's enough. 12 C2 p power 2 q power 10 minus 2, that's enough. If it is given at least, how to write? At most, how to write? More than, how to write? Less than, how to write? This is enough. Everything is clear? Everything is clear? Say yes or no. Somebody please write the message. Somebody please write the message. Tell me quick. Tell me quick. Next, write down Poisson's distribution. Poisson's distribution. Poisson's distribution. P-O-I S-S-O-N-S. Poisson's distribution. Please write it. It is a limiting case of binomial distribution. A limiting case of binomial distribution. That means there will be only 2 possibilities: getting success or failure. But the number of trials are so large. Number of trials n is so large. So large. When compared with the probability of success. When compared with the probability of success. Compared with probability of success. Success. Small p. And the difference between probability of success. Difference between probability of success and failure is also so large. Difference between probability of success and failure is also so large. That is, success probability small p is very small. Success probability small p is very small. when compared with the probability of failure. When compared with the probability of failure. In such a case, probability of getting R successes, probability of getting R successes out of n trials is, P of x equals to R equals to e power minus lambda to lambda power R by R factorial where lambda is mean of the success in binomial distribution. Mean of the success in binomial distribution. In binomial distribution. Mean of the success in binomial distribution. That's why I said Poisson's is also special case or limiting case of binomial distribution. Okay, in which n is so large and compared with probability of success. Say for example, in a bank, if every day 1,000 customers are visiting the bank, 1,000 customers. Among those 1,000 customers, there may be 1 or 2 thieves, or only 5 thieves are there. And every day the robbery may not happen. So what is probability of entering thieves if 5 number of thieves are there? Probability of entering the thief inside the bank will be 5 out of 1,000. That is 5 by 1,000. 5 by 1,000 is small p. It is very small. Now, the probability of getting 2 robberies in a year, 1 year, 365 days. 365 is n. Okay. 1 robbery. 1 robbery means 1 robbery in a day. R will be 1. X is event, that is robbery. N is so large when compared with success. 5 out of 1,000, 5 by 1,000. Or if 2 thieves are there, 2 by 1,000. N is 365, 2 by 1,000. Okay. When doing the comparison, N will be so large when compared with 2 by 1,000 or 5 by 1,000. If the entrance of the robbers or the thieves is 2 by 1,000 and non-robbers means not entering the thieves or non-thieves. Entrance of the non-thieves or the regular customers will be 2 by 1,000 means 998 by 1,000. So P is very small when compared with the Q. If P is thieves, so Q is non-thieves. Okay. On any certain road, every day 10,000 vehicles passes away. So 10,000 vehicles. Out of those 10,000 vehicles, there may be accident may occur for 1 vehicle. 1 out of 1,000 is probability of getting accident. In a year, the probability of getting 2 accidents or 5 accidents. Throughout the year, every day you won't get the accident. So year means 365. Probability of getting 5 accidents means P of X equals to 5. Now the number of trials 365 is very large when compared with the success. So accident may happen for one vehicle, 1 out of 10,000. 365 is so large with the probability of getting accident vehicle, 1 out of 1,000 or 10,000. And this is 1 out of 10,000. For the remaining 9,999 vehicles, you won't get the accident. That is failure of accident. 9,999 by 10,000. So P is very small when compared with Q. In such cases, the difference is very large, so huge. So then we have to use this exponential expression, which is nothing but Poisson's distribution. So yes or no? Yes or no, sir? So this about the thing that you got 1 or 2 problems. Write down. Write down a problem. An injection is injected to 2,000 individuals. 2,000 individuals. 2,000 individuals. The probability of getting bad reaction. The probability of getting bad reaction with that injection is 0.001 bad reaction. 0.001. What is the probability? What is the probability that more than 2 will get bad reaction? More than 2 will get bad reaction. More than 2 will get bad reaction. More than 2 will get bad reaction. So here we have given this injection is injected to 2,000 individuals. Okay. So n equals to 2,000. So clear? N equals to 2,000. And probability of getting success is getting bad reaction. So you will get bad reaction with the probability 0.001. That means 1 out of 1,000 will get badly affected due to that injection. If it is injected, 1 out of 1,000, it is very small when compared with the number of injections. That is number of trials. Number of trials. So here we have to use Poisson's distribution. Note down. The probability of success, that is getting bad reaction, is very small when compared with the number of trials. Compared with the number of trials. Then we have to use Poisson's distribution. Poisson's distribution. Okay. So what is mean? Lambda is mean of binomial distribution. Lambda equals to NP equals to 2 only. Multiply this with that. 2 only. The probability that reaction will happen more than 2 means. You may get for 3, 4, 5, 6, 7, 8, 9, 10, 11, so on 2000. Okay, I think all those is required. More than 2 means I already said 1 minus p of x less than or equal to 2. Okay, less than or equal to 2. This is equal to 1 minus p of x equals to 0, or you may get 1 minus 0 may be affected badly, or 1 may be affected badly, or 2 may be affected badly. P of x equals to so this is equals to 1 minus 0 is affecting badly means lambda is what? Lambda is 2 already. E power minus 2 into lambda is 2. 2 power 0 by 0 factorial plus e power minus 2 into 2 power 1 by 1 factorial plus e power minus 2 2 power 2 by 2 factorial 2 factorial 2 factorial. So yes or no? Speak out. So this is equal to 1 minus my e power minus 2. This is 1, 1. This is 2 into e power minus 2. This is 2 square by 2. 2 into e power minus 2. So 1 minus 5 by e square. Please somebody say the value using the calculator. Somebody say the value using the calculator. Don't take much time. E power minus 2, then you have written in the denominator e square. 1 minus 5 by e square. 1 minus 5 by e means 2.718 something else e square. So what is that? What is that? Tell me, speak out. Anyone can say the value? You are taking much time. Waste of time. 0.32 I think. More than 2 will get bad reaction. In this case is 0.32. Say yes or no? Yes, any response? 0.32. Is somebody write the value? You're not saying anything. Yes. Yes, please speak out. It's okay. Write the next question, which was given again in the gate related to this. Suppose small p is the number of cars per minute. Small p is the number of cars. Number of cars per minute passing through a certain road, junction, passing through a certain road junction between 5 p.m. and 6 p.m. Between 5 p.m. and 6 p.m. And a small p has a Poisson distribution with the mean 3. Small p has a Poisson distribution with the mean 3. With the mean 3. What is the probability of observing fewer than 3 cars during any given minute in this interval. Write down the options. Option A, 8 by 2e cube. Option B, 9 by 2e cube. C, 17 by 2e cube. D, 21 by 2e cube. 21 by e cube. Speak out quick. What is the data given? What is the data given? Here we are having the mean directly is equal to lambda equal to 3. Mean of the binomial distribution. Or you may write it as NP. Here it is clearly given Poisson's arrivals. We had given between 5 p.m. to 6 p.m. on a certain road junction. P is the number of cars per minute passing through this, and P is having Poisson distribution. It is very clearly given it is having Poisson distribution. And mean is given 3. What is the probability that it is observing fewer than 3 during any given minute? In 1 hour, during any given minute, you have to find the required probability fewer than 3. Fewer than 3 means less than 3. Less than 3 means you may not get any car, or you may get 1 car, or you may get 2 cars. Fewer than 3 means maybe 0 or 1 or 2. Fewer than 3 means 3 is not included. So it is strictly specifically mentioned Poisson. P is having Poisson distribution. So you have like e power minus lambda, lambda power 0 by 0 factorial. P of x equals to 1. E power minus lambda, lambda power 1 by 1 factorial plus e power minus lambda into lambda power 2 by 2 factorial. Is it clear? Is it clear? Say yes or no. What is the answer? Waiting is taking too much. You are not responding. You are not saying the answer. It is less than a minute. Within few seconds, you can say the answer. Lambda is given as 3 itself. So lambda power 0, 0 factor, both are 1. 1 by e power 3 plus here again second 3 by e power 8 plus this is e power 3 lambda square is 9 by 2 e power 3. Take LCM, tell me the answer. 2 e power 3 is the LCM. So 2 plus 3 into 2, 6 plus 9. What is the answer? 17 by 2 e power 3. Seventeen by 2 e power 3. This was also asked in the gate. Let's write out normal distribution. Normal distribution. Normal distribution. Please note down normal distribution. The previous one is finished. Everybody got it? If you can send the message, you please send yes or no. Or if you want one more time the explanation, I'll give. Otherwise, we'll continue with normal distribution. Normal distribution. Please tell me quick, fast. Okay. Note down. Normal distribution means it is also a limiting case of binomial distribution. It is also a limiting case of binomial distribution. When n is large, when the number of trials are large, when the number of trials are large, and the difference between probability of success and failure is small. Is small. Then we can use normal distribution. Then we can use normal distribution. Normal distribution. Okay. See, for example, here, if the number of tries are so large, that means you are tossing a coin for 500 times. Tossing coin for 500 times means number of tries are 500. The number of tries are 500. P, getting head may be success. The probability of getting success is 1/2, failure is 1/2. Difference is small. Okay. When you are throwing a cubical fake dice for 1000 times, probability of getting phase 2 is 1/6. Not getting phase 2 is 5/6. There also the difference between 1/6 and 5/6 is small. If you are having the number of trials so large, but the probability of getting success and failure is small, then we can use normal distribution. Normal distribution. Okay. Please note down. So this normal distribution is taken. Normal distribution is taken or considered for continuous random variates. For continuous random variates. Continuous random variates. The normal curve for any continuous random variate x is of the form y plus 2 1/2 e power minus of x minus mu whole square by 2 sigma square. By 2 sigma square. 1/sigma into root 2 pi. You write the sigma, after this it may be confused. Okay. Please note down what are these. Where mu is the mean of the random variable x in binomial distribution. Mu is the mean of the random variable x in binomial distribution. And sigma square is the variance NPQ. And sigma is standard deviation. Positive square root of NPQ. You remember? Positive square root. Positive square root. So this Y denotes the probability density of a normally distributed random variable. Okay. So this term will be of this concept. It is just like a well-shaped insect where you have started. You don't know where you are ending also, you don't know. Minus infinity to infinity. Note down quickly. Note down quickly. Okay. The maximum ordinate is this one. This will happen at mu mean. This is when x equals to mu. This about x values. When x equals to mu, e power 0 will be 1. The maximum ordinate will be, this value will be 1 by sigma root 2 pi. Root 2 pi. Maximum ordinate is 1 by sigma square root 2 pi. And here for this, mean equals to, median equals to mode. I'll discuss this if it is possible today. Otherwise, definitely tomorrow at the end, we'll discuss this. Mean, median, and mode. Okay. So on the right side, you will be having mu plus sigma. Mu plus 2 sigma and mu plus 3 sigma like this. And in the left side also, mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. So please note that diagram. This represents the normally distributed random variable curve. Normally distributed random variable curve. Okay. So here, if you take z is equal to x minus mu by sigma, x minus mu by sigma, this normal random variate is known as standard normal random variate. standard, normal, random variate. Standard, normal, random variate. So, standard, normal, random variate. So, this is for standard, normal, random variate. Mean will be 0. Mean will be 0. Now the graph will be like this. It is distributed about mean previously for normal random variable. It is distributed about mean also. That is 0. Okay. And this will be sigma plus sigma. 2 sigma and 3 sigma. And this will be minus sigma minus 2 sigma minus 3 sigma. This area I am saying the area from minus sigma to sigma will be 68.44%. 68.44%. Area from minus 2 sigma to plus 2 sigma will be 95. This is 68.26. And area from minus 2 sigma to 2 sigma will be 95.44%. Ninety 5.44%. Okay. And the area from minus 3 sigma to plus 3 sigma will be అయిపోయిందా నేను రావచ్చా అసలు 10 10 10 15 అట్లా వస్తాను లాస్ట్ ఓకే area from minus 3 sigma to plus 3 sigma will be 99.21%. Almost 99%. Can somebody say what is the area from minus infinity to infinity? Can somebody say what is the area from minus infinity to infinity? Minus infinity to infinity, what is the area? What is the area? Send the message. Somebody say from minus, if it is minus 3 sigma to plus 3 sigma, if it is 99%, minus infinity to infinity, the area will be 100%. That is integral minus infinity to infinity 1 by sigma root 2 pi e power x minus mu whole square by 2 sigma square dx is equal to 1. Sum of all probabilities in normal distribution will be like this. Okay, you can write this out because that is constant and this value will be 1. Is it clear or not? Is it clear or not? So whenever you have given any problem in normal distribution, convert that into, it will be mentioned normal distribution. Convert that into standard normal random variate. This Z is nothing but standard. Standard. For standard normal random variate, mu will be 0 and sigma square will be 1. Mu will be 0 and sigma square will be 1. Then in such cases, so this is the area that you are getting. You do remember this, then you may get the answers very quickly. We'll do minimum 2 problems on it, which were given in the previous examinations. Make it fast. Make it fast. Make it fast. Please note down. Let capital X be a random variable. Capital X be a random variable. Following normal distribution. Following normal distribution. Normal distribution. With the mean plus 1. Mean plus 1. That means mu x equals to plus 1. And variance. Variance is sigma x squared is 4. Is 4. YB another normal random variable. Capital YB another normal random variable with the mean. With the mean minus 1 and variance unknown. Variance unknown. Variance unknown. If P of x less than or equal to minus 1 is equal to P of y greater than or equal to 2. P of x less than or equal to minus 1 is equal to P of y greater than or equal to 2. Then the standard deviation of y is standard deviation of y. And nothing but sigma y. Sigma y. Please write the options. 3, 2, root 2, 1. 3, 2, root 2, 1. Option A 3, option B 2, option C root 2, option D 1. Okay. So if you understood the concept and following this diagram, you can write the answer very quickly. You can write the answer very quickly. You tell me the answer. Now we have given a condition. The data is clearly written on the board. Okay, P of x less than or equal to minus 1. So convert this into standard normal random variate. Right now, converting this into standard normal random variate. Converting this into standard normal random variate. So conversion means how to do the conversion, sir? How to do the conversion? Z equals what? How to do the conversion? Z must be equal to x minus mu by sigma. Okay. So P of Z is less than or equal to, this is x value, -1 minus mu x by sigma x is equal to P of y greater than or equal to, this is y value, 2 minus mu y by sigma y. This implies P of Z less than or equal to -1 minus mu x, that is -2. Sigma x square is 4, so sigma x will be 2. You have to write positive square root. You should not write minus. Sigma x is 2, -2 minus 2. Sorry. This is -2 already written by sigma x is 2 is equal to. So here also I have converted this into standard normal random variable. P of Z only. X and Y both converted into standard normal random variable. So here also P of Z you will get P of Z greater than or equal to 2 minus mu y. Mu y is -1. 2 minus of -1. 3y. Sigma y is unknown. So this implies P of Z less than or equal to -1 equal to P of Z greater than or equal to 3 by sigma y. Here comes the answer. Amma, for this standard normal random variate, the curve will be like this, starting with -infinity to infinity, either for x or y. It is converted into z. This is z. So we have started at the standard means 0, left side -1, right side you take +1. The area from -infinity to -1 is always equals to area from 1 to infinity. Area from -infinity to -1 is always equals to area from 1 to infinity. This is z, z less than or equal to -1. But we know that P of z less than or equal to -1 means area from -infinity to -1. This means -infinity to -1. Always equals to P of z greater than or equal to 1. That is 1 to infinity. But it is given as P of Z greater than equal to 3 by sigma y. Z greater than equal to 3 by sigma y. So tell me what is sigma y? So this and this are equal. 3 by sigma y equal to 1. What is the value of sigma y? Please write it on, write a message. What is the value of sigma y? What is the value of sigma y? What is the value of sigma y? Sigma y is the standard deviation of y. We have asked the standard deviation of y. What is the answer? What is the answer, sir? No reply. What is the answer? You keep on, yes. 3, that's enough. Standard deviation of y, that is sigma y equal to 3. I repeat this procedure 1 minute. We have given this condition. This is the data. For x, mean, standard deviation are given. For y, mean is given. Sorry, variance is given. Variance is standard deviation. Variance is not given. There is a relation between x and y. Okay, p of x less than equal to -1, p of y greater than equal to 2. Converting this into standard, normal, random, variate. Here you have right there. Standard, normal, random, variate. P of z less than equal to, this is x minus mu by sigma. So whenever it is x is converted to standard, x minus mu x by sigma x. Y converted to standard, so y minus mu y by sigma y. I have substituted, you have got this, but according to the diagram of the normally distributed, standard normally distributed random variable diagrammatical area, area from minus infinity to -1 is same as that of area from 1 to infinity. It is a symmetric. Area from 0 to infinity and area from minus infinity to 0. Both are same. That's why I had given you the diagram. Okay. So area from that is equal to nothing but area from 1 to infinity. So this is actually equal to greater than equal to 3 by sigma y equal to z greater than equal to 1. So both are compared. 3 by sigma y equal to 1. Sigma y equals to 3. Finished? Yes or no? Say yes or no? Right, next another problem. Let x be a normal random variable with the mean 1 and variance 4. Variance is sigma x square. Variance is sigma x square. Variance 4. The probability p of x less than 0 is p of x less than 0 is p of x less than 0 is. Write the options. Option A 0.5, Option B. Greater than 0 and less than 0.5. Greater than 0 and less than 0.5. Option C. Greater than 0.5. And less than 1 and less than 1 or 1.0. Option D 1.0. So it takes again less than a minute to say the answer. We have given mean, variance, that means standard deviation also will be given. Also was given. Okay. So we have asked P of x less than 0. Converting this into standard, normal, random, variate. P of z less than, this is x value, 0 minus mu x by sigma x. Only this sort of problems were asked and will be asked based on the diagrammatical representation. P of z is standard, normal, and variate. Note down. Converting the normal random variable x into standard, normal, random variate z. Z equals x minus mu by sigma. X minus mu by sigma. This is equal to P of z less than 0 minus mu x by sigma x. This is equal to P of z less than mu x is 1. So minus 1. Sigma x is 2. Sigma x is 2. Sigma x is 2. Okay. Now you can say the answer. What is P of z less than 0? This is normal random variable curve. If it is converted into standard, it will be 0. This is z. This is for z. 0 less than minus half. Minus half will be this side. Less than minus half means up to minus half. What is the area from minus infinity to 0 will be 0.5. And 0 to infinity will be 0 to infinity will be 0.5. 0.5. Is it okay? Now, what is the area from minus infinity to minus half? P of z less than minus half means the area from minus infinity to minus half. Tell me which option is correct? Which option is correct? Everything I have written. Everything I have written. Everything I have written. Greater than 0 and and less than 0.5. From here to here, this is the area that you need to find. It is less than 0.5 and greater than 0. Greater than 0 and less than 0.5. Am I right or not? Just one step and drawing, understanding the diagram. Conversion of normal variable into standard normal random variable. Please say yes or no. Please type. If you are able to understand, please type. If you want me to explain this again, I will. If you are just keep quiet, then I have to move on to the next topic. Uniform distribution. Uniform distribution. Right on. Uniform distribution. Uniform distribution. Just take the definition and we will do one example. That's you people never expected, or you have got very less extent of time. You have got the problems from uniform distribution. But anyhow, you have to know about it. In both the cases, you have to discuss the uniform distribution. Discrete and continuous. Right now. If x1, x2, so on, xn. If the variables x1, x2, so on, xn are uniformly distributed, then probability of happening xi equals to 1 by n. Happening xi equals to 1 by n. Suppose if a coin is tossed, head, tail are uniformly distributed. Probability of getting H and probability of getting tail 1 by 2, because 2 events are there. When a cubical fake dice is tossed, then also what you can say, 6 events are there. Phase 1, phase 2, phase 3 up to phase 6. Probability of getting any phase equals to 1 by 6. Okay, that is discrete random. For discrete random variable, probability of uniformly distributed discrete random variable. X1, x2, so on, xn are uniformly distributed. Probability of happening such uniformly distributed random variable equals to 1 by n. And sum of all probabilities, sigma equals to 1 by n. P of xi equals to 1. P of xi equals to 1. Okay. Next. If random variable xi is continuously, please write. If a random variable xi is continuously distributed, over an interval closely AB, over an interval close to AB. An interval close to AB. Then y equal to f of x. Y equal to f of x with a probability density function. Probability density function. Probability density function of the above continuous random variate. The above continuous random variate. Continuous random variate. Already we discussed what is continuous, and also we have used in normal distribution now. Continuous random variate. Then sum of all probabilities sum of all probabilities then the sum of all probabilities is you have started at A, ended at B. For continuous, you have to use sigma, sorry, integration. Integral A to B f of x dx is equal to 1. Integral A to B f of x dx is equal to 1. This is in case of continuous random variable. How you have to write? How you have to write? How you have to write the that how the probability density function is defined? How the probability density function is defined? Come on, tell me how the probability density function f of x is defined. Now f of x is defined as f of x is defined as 1 by b minus a. For a less than or equal to x less than or equal to b. 0 otherwise. 0 otherwise. 0 otherwise. Zero otherwise. Is it clear? So here, if you want to find this value, integral a to b, f of x dx means 1 by b minus a. F of x is 1 by b minus a dx. So this is equal to 1 by b minus a into integral dx is x, limits from a to b equal to b minus a by b minus a equals to 1. Okay, this you will get based on this definition. The probability density function for uniformly distributed random variables. For uniformly distributed random variable xi is, if xi is uniformly distributed and is continuous over closed AB, then its density function y equal to f of x is defined like this, and from this you can write this. Is it clear now? Say yes or no, is it clear? Say yes or no. So write down a problem given in the gate previously. Two independent random variables. Two independent random variables. X comma y are uniformly distributed on the interval closed -1 comma 1 on the interval closed -1 comma 1. The probability that that maximum of x comma y is less than half is less than 1/2 is 1/2 is. Please note the options. Please note the options. 3/4, 9/16, 1/4, 2/3. I repeat, 3/4, 9/16, 1/4, 2/3. 2/3. Okay. So here the thing is, what is given? X and Y are both are uniformly distributed over the interval close -1 comma 1. Okay. So P of X will be probability density function, that is f of x of x. F of x equals to what? F of x equals to what? 1/1 minus of -1, or -1 less than or equal to x less than or equal to 1, and 0 otherwise. 0 otherwise. Okay. 0 otherwise. So now probability of x less than half is nothing but x less than half is nothing but you have to take from -infinity to half f of x dx. Okay, less than half means from anywhere you can take up to half. Even equality is there, you can write the upper limit now. Even if less than is there, you can write up to upper limit as half. Okay, so here this is equal to from -infinity to -1. What is the value? 0 dx plus from -1 to half. -1 to half you have to find. From -1 to half, what is the value? 1/2 dx. I repeat, It is from minus infinity to half. From minus infinity to half means minus infinity to minus 1 you can take. So minus infinity to minus 1 means otherwise it is 0. Now minus 1 to half will be 1 by 2. So what is the value? This is equal to, this part is 0, 1 by 2 into x limits from minus 1 to 1 by 2. So this is equal to 1 by 2 into 1 by 2 minus half minus 1. That is 3 by 4. P of x less than half is 3 by 4. It is not the answer. Don't be get confused. We have asked probability that maximum of x comma y is less than half is. Probability that maximum of x comma y is less than half. So probability x less than half is this. Similarly, f of y will be 1 by 2 minus 1 less than equal to y less than equal to 1. And 0 otherwise. And p of y less than half will be same. That is also 3 by 4 because same definition. Both are defined over the same interval. Both are uniformly distributed. So the important thing is probability that maximum of x comma y less than half means p of x less than half and p of y less than half. P of x less than half is 3 by 4 and means multiplication. P of y less than half is 3 by 4. So this is nothing but 9 by 16. So the question may be asked, what is probability x less than half? It's simple. That is also given among the option. You may get confused. But here we have asked the question, probability that maximum of x comma y less than y less than half means x less than half and y less than half you have. The probability of x comma y minimum of x comma y means 3 by 4 only. Minimum of x comma y will be either this or that means only 3 by 4. Maximum of means 3 by 4 into 3 by 4. The answer is 9 by 16. 9 by 16. Everybody got it? Say yes or no. Please send the message. Yes. So these are the important things or important types which were asked in the previous examination. And there is one simple concept, mean, median, mode, and the standard deviation. That is actually in aptitude part. It is common to both aptitude as well as this one. So aptitude and as well as this one. So that we will continue tomorrow. This finishes probability and statistics. So maximum of 5 marks you can expect from it. Okay. Vasnanan, 2 minutes. 2 minutes. Okay, everybody got it? That we will continue tomorrow. So main median, just only the definitions are required. But there is one simple thing which is important is standard deviation and coefficient of variation. So if you know that, that is actually an aptitude part. Aptitude here also it is mentioned. We may do some few examples. That may take a few time and it takes 1 hour, less than that. Afterwards, we will just discuss the doubts, particularly if you have any doubts on the discussed topics, that we will do it tomorrow. Okay. Say it is okay. No response. Okay, then you can take leave now.